Good afternoon, everyone, and welcome to this week's Building Science Deconstructed live webinar. This week we're featuring Oak Ridge National Laboratory's Building Science Advisor, a tool for better performing building envelope solutions presented by Philip Boudreaux. My name is Peter Barrett. I am the Product and Marketing Manager for cosella-dorken. For everyone's information, we will have a live question and answer period at the end featuring 2 additional panelists. Additionally, if you have questions during the webinar, you may use the Q&A button that's available on the panel, and you may also you may also put questions into the chat, although we prefer in the Q&A. We will do our best to answer questions during the presentation. We will get to them at the end, and if we miss any, we will be publishing them all in a paper at the end. Also, if you miss anything during the presentation, don't worry, this is being recorded and will be available for later viewing. This is brought to you by Dorken Systems. We've been manufacturing building products for 125 years. This is a shot of our head office in beautiful Herdecke, Germany. In North America, we are based in Beamsville, a little town about 40 minutes across the border from Buffalo and about an hour west of Toronto. Today's presenter from Oak Ridge National Laboratory is Philip Boudreaux. He is a staff member at Oak Ridge's National Laboratory in the Building Technologies Research and Integration Center. Over the last few years, he has helped develop the Building Science Advisor, the subject of today's presentation. You will see that it is an online tool to aid in the design of durable wall systems. His other research interests include advanced drying appliances, probabilistic modeling, and image-based envelope leakage detection systems. Without further ado, here is Mr. Boudreaux.
Thank you, Peter. I'm going to share my presentation here. Okay, so thanks everyone for attending. My plan for the presentation portion is to show you some PowerPoint slides that give a background of the tool and why we developed it, and then give a live demo of the tool. So most of this presentation was adapted from a talk that we did at the end of 2019 at a building conference. And there's a paper associated with that. If you wanted more information, you can probably find that on the web. So this has been a team effort, and these are all of those who have helped. Many from Ornell are on our development team. And then we've also had others help us as subcontractors and giving us great feedback on the tool and that we've been able to iterate with and improve it. And so I thank everyone for that who helped. Also, Eric Whirling from DOE is our sponsor from the tool, so it has been funded through the Building America project. And so thanks to him as well. So why did we develop this tool? Well, the short answer is that building is getting more challenging. And so as we compare buildings today to buildings 100 years ago, we're asking them to do a lot more things. So 100 years ago, the walls were structural, they held up the roof, and they kept the rain out, and that was about it. Now we ask the walls and the envelope as a whole to do a lot more. Since air conditioning started, we try to keep that conditioned air in and not let the outdoor air in to save energy and also to provide comfort. And so we've added thermal insulation to the walls. We've also added air barriers even more recently, try to keep the air that we've conditioned in to save money. We've also added vapor retarders to one side or the other of the wall. And so as you combine all these things, you can have things happen that you didn't quite plan for. And so this is the aim of the tool, to help builders decide what components should go where in a wall and how to build them both energy efficient and in a durable way. Another motivation for this tool is that there's more people out there who can investigate a house and determine problems with it. So you have inspectors, home energy raters, you have new tools that they can use to see inside the wall and see what's going on. For the example here is this IR camera where they can see where the thermal breaks are in a wall, which goes into gives you some insight on the construction, how well the building was constructed. And so people are watching, people can see a builder's work. Also with the internet age, people can complain about any work that they have done on their house. So others can go and read this. So this is definitely something that we want to avoid. And the way to do that is by building walls that work. There's also been a recent poll by Home Innovations Lab, and they asked builders what their top challenges were as they try to build code compliant buildings that are energy efficient. And you'll notice among the top two dealt with moisture performance, both of walls and attics. And so this is of critical concern. As people build energy efficient walls, they realize that more attention needs to be paid to make sure that they're durable. So how do we help manage this risk? Well, we provide accessible educational information for designing durable, energy efficient buildings. And that's the aim of the Building Science Advisor. And so there's a URL link here that you can go and play with the tool. And so now I'm going to tell you about the tool itself and how it works. But before I do that, I think we have a poll that we're going to bring up. And we'd just like to ask you if you've ever heard of the Building Science Advisor before. So I'll give you a few seconds to answer that. Okay, so it looks like the majority of you haven't heard of the Building Science Advisor tool, so that's great. So hopefully those who have heard it, this will help you know a little bit how it works on the back end, and maybe that'll be more useful to you then. Those who haven't, I'm pleased to introduce it to you and hope that it's a great benefit to you and your business. Okay. So the Building Science Advisor is an expert system. And so an expert system has been employed in many different industries. And the idea is that you have a computer that kind of acts like an expert in the field. So if you have a problem and you go to the computer, it'll be like an expert telling you how to solve your problem. And so that's the idea behind the Building Science Advisor. And there's three parts to this. So there's a user interface. That's the part that when you go online, you enter in what your wall is, how it's built up. And then on the other side is the knowledge base. The knowledge base is really just a database of rules, and we'll talk a little bit more about that. And it's populated with hydrothermal modeling results as well as expert opinion. And then the inference engine just connects those two. And so we'll go through each of these, not using these same terms because it gets a little confusing, and really it's simple what's going on. And so I'll explain that to you. So the user interface of the BSA is a web tool where you can go through each part of the wall and tell the tool how you've built it up. There's many different materials to choose from for each category. And as you finish up, at the end of the tool, it gives you a fail or a pass rating or inconclusive as far as the durability performance of the wall. And so that's the main focus here is durability. It also gives you, it compares your wall to code, and this is just looking at the insulation level to help you know if you're meeting code. And then one of the most interesting parts is that we provide guidance on the wall, and if it's a fail, then it'll tell you how you can fix it, what you can do, what you can change in the wall to make it more durable. And so we'll go through this in detail as we do the live demo, so I won't spend any more time on the user interface. The next part is the knowledge base. So really this is just, you can think of it as a database or an Excel spreadsheet. It's basically just a bunch of wall descriptions. You can think of it as an if-then statement. So this is one example of what one of those wall descriptions might look like. But basically, for each component of the wall, it says that if what the user entered matches all these things, then it'll match on this if-then statement. And so if it matches on this, you'll see at the bottom where it says moisture durability, it's red. That means it failed. And then there's guidance that's displayed to the user. And so we have a bunch of these if-then statements in a database. There's over 500 of these rules. And if you notice, sometimes the characteristic is marked as a wildcard for this particular description, which means that it doesn't matter what the user entered for WRB permeates, for example, it'll still match on this rule. You can also see there's sometimes where there's more than one input, for example, for wall structure. So any 2x4 construction, whether wood or steel frame, would match on this rule.
Philip,
So
we have a question from the audience on this section.
Okay.
Hector Albrecht would like to know, for this tool, would you be able to select exact manufacturer components?
No, we don't have exact manufacturer's components. It's more a general within a category. So we don't have any trademark products or anything like that. And hopefully when we go through the live demo, that'll help Hector kind of see what we've done. Okay, so if you think about there's 500 of these rules, and then the wild cards and things that are in here, there's millions of combinations of user input that can match on these rules. So it gets a little complicated when you think about how much information is actually in this database. So as I mentioned, sometimes simulations were used to fill this database. So we've done simulations for wood and steel frame walls for these different categories, depending on what type of continuous insulation there was on the wall, what type of cladding, what type of, if there was an air gap or not behind the cladding. And so what you'll notice if you just look at this is, for example, continuous insulation has three categories: impermeable, permeable, or none. And so as we built up these rules, they're in product category. So we really look at the moisture performance of the different materials, and we group them into categories. This helps us keep the database somewhat manageable.
Philip, a question from the audience.
Yes.
What different size studs can you select within the system?
So there's 2x4 and 2x6. And then you can also select between 16-inch on center and 24-inch on center. And then wood and steel. So those are different combinations of stud walls that we have. We also have CMU walls that we've done simulations on to help populate the database, and also categorize as either internally insulated or externally insulated. And so I will mention, as we go through the live demo, I'll walk through the different options, and so hopefully this will help everyone who's listening kind of understand what's going on. So there's also other rules in the database that aren't based on simulation. So there's rules to make sure we're meeting certain parts of code. So this, for example, if you're in marine climate 4 or climate 5, 6, 7, and 8, so basically marine or colder climates, this class 3 vapor retarder part of the code. So that's in the database as well to help users get that advice. Also, as I mentioned earlier, we check to see that the wall insulation rather, meets code.
Philip, for our Canadian friends, can you clarify that this is just U.S. code, although it may be transferable to Canada?
Yeah, so this, it's the 2015 IRC code is what we're checking against.
Thank you.
Yep. And so the inference engine is just what connects what you've input in the tool to the database. And so it converts the components that you input into their relevant material properties. So there's just one example for the weather resistive barrier. it's categorized into 3 categories, whether it's less than 1 perm, between 1 and 10 perm, or greater than 10 perm. And so that's similar to all the materials. We section them off into categories and really think about a family of materials all perform similarly in the wall. And then the inference engine searches the database for a match. It displays the worst match that it hits. So these are the different options: fail, inconclusive, and pass. And really, inconclusive means that the wall could go either way, and it depends on a lot of different variables. For example, indoor climate. That right now we're basically taking the average indoor climate as a basis for these rules, but we hope to change that in the future, and I'll talk about that in a little bit. And then the guidance for all the matches are displayed. So that's the part of the tool that will help the user make their wall more durable. So I wanted to talk a little bit about the future of the Building Science Advisor, because we are currently doing more work on it, and we hope to do a lot more and increase the capabilities in the future. So right now we're working on a retrofit path, where if you were coming to an existing building and you wanted to retrofit the wall, a guide that would help you do that. And so a lot of this is helping you figure out what's in the current wall, if it has moisture problems, how to fix it, and then making recommendations based on what the existing wall is, and then climate zone and things like that. And then also have some user input as far as how far they want to go.
Would there be significant updates, Philip, for the 2018 code?
Can you say that once more, Peter? I didn't hear the beginning.
Yes, would there be significant updates for adaptation to the 2018 code?
We haven't talked about that yet, but we do plan on doing ongoing maintenance to the tool. So updating it to the newer codes is definitely something that I foresee that being part of. So another thing that we want to add is probabilistic modeling. And so basically, when you do a computer model, you assume a lot of things. You assume single inputs. But the reality is that once a wall goes into the field, it sees a lot of different conditions, a lot of different indoor conditions. It might be the same house, but depending on the family that lives there, the indoor condition is going to be different. And so this would take that into account. So you'd have a lot of different inputs that are ranges instead of single values. And then what you'd get out is a range of performance. So just as an example, there's mold growth index. So a wall that has a lower number is better. A higher number is not good. And so if you have a wall where most of the time it's over between 0 and 1, then it's a lot better performing than if a wall has a long tail, for example, out into the 5 and 6. And so this would really help you get an idea of how a wall would perform overall in the many different homes that it could be put in. So something else that we want to do is add more envelope components. So have a track for roofs or a track for foundations. And so these are some of the things we're thinking about as we expand the tool.
So Philip, that brings us to a question from the audience.
Yes.
So what we're seeing today is for above grade walls only.
Yes, that's correct.
Thank you.
Yeah, and we focus on new construction as well. Okay, so that ends up the presentation part, the slides. And so I'm going to stop sharing this and start sharing my web browser. Okay, so you should be seeing the Building Science Advisor webpage. And so once you log in, this is what you'd see. You can continue as an expert or as an educational path. And the difference is that on the educational path, the help menus are all expanded, so they're always shown. In the expert path, they're hidden, and you can click on a question mark button and it'll give you the help if you want it. And so we'll just go down the expert path since it's easier to see on a single screen. And so as a user, all your previous walls that you built up are saved, so you can go back to one of those and continue playing with that, or you can create a new wall. We'll go ahead and create a new wall. So the first thing you come to is what climate zone you're going to build in. So we'll pick a cold climate here, and then the map's highlighted to show you where you've selected. And then next is the cladding for the wall. And so you'll see many different options here. Again, none of them are trademarked to a certain company, but more general categories. So brick, cement, siding, vinyl, etc. We've categorized these into two groups, whether they're absorptive or non-absorptive. For example of absorptive would be stone or mineral stucco, and we'll click mineral stucco for here. And if you go to structure, that lets you pick the sheathing as well as the structure of the wall. So here we'll stick with OSB, and we'll go with 2x6, 16 on center wood frame wall. You can see some of the other options here, other framed walls, wood and steel, SIP panel walls, and CMU walls. After that, we're on to the insulation of the wall. And so you can select continuous insulation and cavity insulation. So for continuous insulation for this wall, we'll select EPS. And then once you do that, you have a drop down for continuous insulation thickness. We'll pick 2 inches for that. And then for cavity insulation, you also have a lot of options. So we have the fiberglass insulation at different R values, cellulose loose fill, some spray foam, splash and batt, mineral wool, etc. So we're just going to do fiberglass batt. So this will be R21 because we're in a 6-inch wall. Next is a outboard weather control of the wall, and so we will select none for this demo, and for the WRB, we'll select a permeable fully adhered membrane. And finally, you come to the interior side of the wall and look at the vapor control there. So we'll pick latex paint. And then for vapor retarder class, we'll pick poly sheet, so a vapor barrier on the interior side. And then you can pick the expected air tightness. Currently, the only thing that this selection does is tell you whether you're code or not for the air tightness. And then once you're done, so we put in all the wall components that we plan on using, we go to results. And so this first off is telling us that this wall will fail from a moisture durability performance aspect, yet it does meet code as far as thermal insulation goes. So if we go down here to the durability guidance, we're told that the wall can absorb water because of the absorptive cladding, and it tells us that we should put ventilation behind the exterior cladding. And then it has this button for more information. So if you click on the more information, it brings up a PDF that is really meant to help educate the user. So what you have here is a section on what the issue is, and then if it stays like that, the problem that it could create, and then preventative action. So how do you stop this from happening? And so the recommendation is for an air gap, and this gives you some information about recommended widths for different wall designs. So if we go back to the Building Science Advisor, if we take this information and we say, well, we want to put an airspace, then the wall passes. And so this gives you an idea of how the Building Science Advisor works. I'm going to do one more wall to show you just another example to help you understand. Again,
we have some questions from the audience that you may want to cover on this second wall. These are mostly around some of the choices available.
Okay.
we have the question: can you select only one cladding at a time?
Yes, you can only select one at a time.
Does this tool have metric units?
It doesn't currently, but that's come up before, and that's definitely something that we can add.
Is EIFS listed as one of the wall choices?
That's a good question. If it's not, you can basically trick the tool to have that. We'll look at that as we go through.
So a couple more questions about the wall. What about a double stud wall?
We don't have that option, but we have had a request for it before. So as I mentioned, we have funds to maintain this tool, and so we can add wall designs as we go.
Can you put in thicker insulation than 4-inch?
But currently, that's the thickest that we have.
Okay. All right. We'll get to more later. Thank you.
Okay. Yeah, you're welcome. So we'll start with a new wall again. And so for this wall, we'll go to a milder climate. So we'll pick a 4A. For the cladding, we'll do another absorptive cladding, but we'll pick stone instead this time. Yeah, so for the EIFS, you can pick mineral stucco, which would roughly give you the same. So mineral stucco without an air gap would probably give you the same results. So, if we go to structure, we'll stick with the OSB as well, but we'll go with a 2x4 wall, 16-inch on center. For insulation, we will have no continuous insulation for this one. We'll stick with the medium performance fiberglass, which would be R13 in this example, since we're a 2x4 wall. And then for water control, we'll pick none again. For the WRB, we will stick with the permeable, fully adhered membrane. And then for the interior control, stick with latex paint. We'll go with craft paper for the interior vapor retarder, and stick with the free air change per hour. We'll go to results. So again, we see this wall fail, and then it's below code. So this guidance is a little different. So it says, again, that it can absorb moisture, but it gives us some other options to fix it. It says that you can add continuous insulation and or add an air gap behind the cladding. And so again, there's another PDF that you can click on, and it brings up a discussion on vapor open walls and how to design those in a way that works. And so if you go down to the preventative actions, it talks about having a certain ratio of continuous insulation on the outside to keep the inside of the wall warmer so that you don't get condensation there. And so if we take that advice and add continuous insulation, we'll add 2 inches. And there you see, now we meet code, and we also pass from a durability standpoint. So that is the end of the live demo part of the Building Science Advisor. So I hope that gave you a little taste for what's there. So I invite you to go and play with it. There is, if you find something that you'd like to mention, you can go down to the bottom, and there's a place where you can email the site administrator. And so that comes to us, and so we can investigate any issues you might find. All right, Peter, do you want to ask more questions or go to the panel section?
I'm going to bring the panel on so we can discuss some of these questions there.
Great.
And I think that's the next step. So one second,
Awesome.
we should be right there. All right. So here in the Q&A section, I would like to introduce our guest panelists. Our first guest panelist is André Desjarlais. André Desjarlais is the program manager for the Building Envelope and Urban Systems Research Program at the Oak Ridge National Laboratory. He has been involved in the building envelope and materials research for over 45 years, first as a consultant and for the last 25 years at Oak Ridge's National Lab. Areas of expertise include building envelope and material energy efficiency, moisture control, and durability. Our second guest panelist is Gavin Semrow. He is a contractor. He founded AI Restorations in 1996 after moving to the greater Philadelphia area from Wisconsin, where he had studied architecture at the University of Wisconsin-Milwaukee. Over the past 23 years, Gavin, through AI Restoration, has continually worked to improve the technology behind water, moisture, and air management issues with the exteriors of homes. So let's start out with some observations first from Gavin.
Thank you, Peter. We just want to say thanks a lot, Philip. It was very impressive. I've had a chance to play with it a little bit myself, and have to say it's an extremely useful tool, especially when there is a problem. It seems like that going into those PDFs and stuff like that really give us an opportunity to make a lot of solutions. So awesome, I can say that word. So I myself had a couple questions as a contractor, and then I've kind of been following along with some of the questions coming through. So I'm hoping that maybe some of the questions I ask will kind of interpret some of those too. So in my industry of remediation, I truly believe that airspace is almost a must. I guess I look at that airspace as to maybe make my systems a little bit more forgiving, because as a contractor, although we try for perfection, we don't always make perfection. Just wanted to know your thoughts on that.
This is André. I'll field that question. If you use the Building Science Advisor extensively, what you will find is when you design walls that include an airspace, I don't think I've ever come up with a combination of wall system where the inclusion of an airspace leads to a failure. So it certainly is a very powerful component of a wall system for controlling moisture ingress, especially for wall systems that have absorptive claddings and a lot of wind-driven rain. So in a couple of areas, Phoenix is an example where you don't have a lot of solar-driven, wind-driven rain into wall systems. You can probably get away in some assemblies without an airspace, but I think it's true to say that in all cases, the addition of an airspace makes a wall more durable. So it's kind of like belt and suspenders. You may have a wall that's durable without an airspace, but adding an airspace just gives you an added level of protection for the performance of the wall.
So André, in the same vein, and I think Gavin can chime in on this as well. We have a question from the audience who wants to know exactly how do you add an airspace behind a stucco wall?
Obviously, you need to use some form of spacer to accomplish that. There are a number of insulation systems that have routed spacers or routed portions which allow you to create the airspace. There are a number of different products that can be used to create the airspace. Chicken wire can do that. In each systems, you can use concrete fingers to create the airspace. So there are a wide variety of mechanisms to do that. Brick, obviously, you just step it off to create the airspace. So each system has its, I think, their own means of creating that airspace behind the absorptive cladding.
I'll maybe chime in here for a minute, just speaking from a contractor. one of the products that we do use is one of the Dorken products. It's the Delta Dry, just for ease of application. We call it dimple mat, and by just basically applying that to the exterior of our walls, really makes it easy and simple, and we're just really guaranteed to have the proper airspace and ventilation. So that's our main product that we're using for making that airspace.
Thank you.
So another question, if it's all right, here's kind of keep going. I trying to watch the time a little bit. I guess we're doing all right, but I guess to Philip or Andre, I have played with the program a couple times, and one of the things that, and speaking from a retrofit, not a new build, because I'm a contractor to retrofit, so going in to fix something, it's hard for us to put continuous exterior insulation on a retrofit for many reasons. If I, as a contractor, go on, can I build a wall that will pass without exterior continuous insulation?
If you're, I guess it depends on what you're trying to accomplish. You're probably going to have a hard time meeting the most recent energy codes. If you're looking at a wall system that has 2x4 framing, you can obviously improve the energy efficiency by filling the cavity. You could probably go to a high density spray foam, which will give you more R value per inch, but you're going to get pressed to accomplish to meet the code, and especially in more northern climates. So you're going to have a hard time meeting the energy code in those situations. I think part of the purpose of the tool is to verify that you're not going to be creating a moisture problem if you go in and make an energy improvement. And I haven't actually come up with a specific situation that accomplishes this, but I could foresee a combination of a water-resistant barrier, climate, location where the of insulation may cause a problem. And in which case, the recommendation is you shouldn't make that insulation improvement, because you're going to, if all you're doing is accessing the wall system from the interior side, adding the insulation is going to save you energy for the 6 months before you have to tear the wall down and repair it for the moisture problem that's just created. So if the solution is don't do it, then so be it. Now, I haven't actually run into that combination of conditions that accomplish that, but that's the purpose of the tool, to lead you or to suggest that to look at what you're proposing to do and assess whether or not you're going to create a problem, and if so, act accordingly.
Right. Thank you. Kind of going down my list here a little bit, I tried to write down a few things. Is this something as a professionals we would want to share with the customers and the homeowners, or is this something we really want to just kind of keep to ourselves? The tool.
Yeah, Philip, you wanna take that one?
Sure. Yeah, no, even though the tool was aimed at someone who's familiar with residential construction, I definitely think it can be used as a tool for a builder or contractor to go to a homeowner or a buyer and say, look, this is what this wall looks like, and it's going to perform well. And so, yeah, we'd like you guys to use it in any way that can help you. That's why we built it.
Yeah, I would just add to that that the part of the purpose of the tool is to encourage energy efficiency improvements and to waylay concerns of building owners that they read somewhere on the internet that adding insulation caused problems. But here's a tool that is showing very specifically their location, their construction, the ramifications of an improvement for their specific situation. And if it shows that there's going to be a problem, then don't go that route. In most cases, it's going to show that there is a way of creating that wall that can be both energy efficient and durable. There, in most instances, that combination exists, and this tool hopefully helps you find that combination pretty easily.
I was actually, thank you. I was looking at a couple of the questions that just kind of came in, and one of them that I did like that just came in was, does this tool only work for residential? Can it be used for commercial projects as well?
Go ahead, Philip.
So it's currently tailored towards residential. And so for example, the indoor condition would assume an average condition, which might be different in a commercial building depending on what type of building it is. But in general, if that commercial building wall can be built up currently in the BSA, then it could be used. Just with that caveat about if the indoor condition's different, then you might get different results.
Yeah, just to follow up on Philip's answer, the color of money that was used to develop this tool comes from the residential research programs at DOE. So the focus is on residential construction. But as Philip pointed out, in each system, with steel studs is probably more typical for light commercial than it is for residential, and those combinations do exist. So if you can create the wall, then it should be fine. But we didn't focus on trying to include all of the typical wall systems that would be used in light commercial. The focus was trying to get as many of the residential systems in place. And as you know, some of your earlier questions suggested, we tried to cover 98% of the waterfront. There are certainly a lot of specialized systems. Larson trusses, for example, are another case where that's not been included in the database because it's just such a niche product, and we didn't have the energy or the budget to add all of these very, very small market segment systems.
Excellent. I've got one more question on my list. I think you've kind of answered it already, but maybe you can summarize a little bit. Is what are some of the limitations of the BSA?
Okay. Probably the largest, the biggest limitation is that there are, and Philip alluded to this earlier, there are systems, the moisture performance of wall systems isn't limited to the components of the wall. It can be impacted by both the indoor and the outdoor environment. The database is created based on expert advice, and as Philip pointed out, some computer simulation to backfill the holes that we didn't have enough opinion to create a rule. And when we create these rules and we do these simulations, we did them. We didn't do them probabilistically, as Philip suggested. We did them with a single input. And so, for example, and probably the biggest assumption is, what's the interior relative humidity? We assumed average levels of interior relative humidity for all of the computer simulations. So if you're in a home that has, a lot of people who produce a lot of moisture, and the moisture load inside of that building is higher than what we assumed, then you may get a failure where the tool tells you you're getting a pass. And similarly, we're using weather files that have a typical a rain profile that tends to be fairly severe, but not not the worst year possible. If you're if you have a wall system that is suffering from solar-driven moisture from the exterior, but in your climate, the rainfall has been, you're in a drought for the last 3 years, and the rainfall has been a lot less than what we use in our calculations. Then the tool will tell you it's going to fail, but you could be staring at a wall that's just fine. So The factors outside of the construction of the wall are things that aren't handled in the tool right now. That's probably the biggest limitation.
So along the same lines, Andre and Philip, are there any allowances in this for thermal bridging or windows?
The tool right now, in the thermal performance section, it includes the thermal bridging impacts. So that's captured. For moisture control, what we have typically seen is that the bulk of moisture problems are in the cavity and not near the structure. So where we're backfilling with simulations, we're typically looking at the center of the cavity. The expert advice is, folks going out and dissecting buildings that have failed. So certainly I would presume that if there was a situation, created by thermal bridging, which was compromising the performance of the wall, then that would be captured in their forensic analysis. So the answer is most of the time, yes. I think we're trying to accomplish that. I'm not sure we're 100% successful in doing that, but that's if people, part of our desire to chat today is to have people look at the tool, and if your experiences are different than what the tool is proposing, then we would like to hear about it. If there are bugs or if there are a lot of experience that suggests that the tool is making a recommendation that is inappropriate, please tell us so that we can analyze the situation and find out if it's a situation where it's the environment which is creating the problem, which we can't control, or if this if one of our rules is incorrect and needs to be modified.
Thank you. Yeah, and just to add to that, the question about windows. So other than the great difference in thermal performance, a typical issue with windows would be water intrusion around that window if it's not flashed well. And just I wanted to note that in the BSA, we assume that there's no bulk water issue, that the wall is built well, and mainly it's looking at diffusion and things like that instead.
So Philip, would you be kind enough to duck back to your first wall construction and simulation in the tool and take us through that one more time?
Sure. Okay, so the first wall, so that was a 6A wall. Is there a particular question on that one?
Well, many of the questions are focus around what choices are available.
Okay.
Recognizing that you don't have everything in here yet. But.
Okay. So yeah, so maybe I can just click through the different menus. I don't know if that would help. As I mentioned, for the cladding, there's really two groups, so absorptive and non-absorptive. And typically, if with all these materials, if you have one, it might perform similarly to one of these others, even though your particular material is not listed. And one of the reasons why I kind of wanted to mention the way that we group things is because that can help you decide what to pick as a surrogate. Yeah, typically here we have things that absorb water like brick, and things that don't, like vinyl siding. Structures, yeah, someone mentioned double stud, so that's not here. We really tried to focus on the majority of the market, which that's wood framed walls in the U.S.
Are you able at all to reorder the layers, or are the layers fixed in the tool?
The layers are fixed in the tool.
You
can't reorder them. Maybe I'll just click through and talk, and if there's a question that hits one of these, you can mention it, Peter. So for continuous insulation, yep.
Philip, I see one of the questions that came up from the audience was, does using rock wool rock wool need an airspace?
You want to take that one, Andre?
Oh, we lost Andre.
Yeah, so just if you go to insulation, so that would be the most permeable continuous insulation that's available here on this list. So as far as vapor control, you basically don't have any of it with that continuous insulation. So if, depending on your climate, if you need exterior vapor control, then you'd want to add it in some other way. And then, like Gavin mentioned, having the airspace will help all around. In any bulk water that does get in, it'll help. If there is a way for the air somehow to go through that mineral wool, then again that will help from a moisture perspective, but not so much from a thermal perspective. If Andre, if you're back, feel free to chime in.
Well, I have to remember to unmute. I think that question is the perfect type of question as to why we created this tool. You don't need to ask an expert that question. Once you develop confidence in this tool will answer that question for you. So the answer, of course, is it depends, and it depends on all of the other layers and where the building is. But that's the exact reason why this tool has been constructed. You can look at the use of rock wool either as continuous insulation or as cavity fill or as both in any climate with any combination of water resistant barrier, any combination of interior moisture control, and come up with a recommendation of whether or not it will be create a durability problem or not. So thank you for asking that question. That's a loaded question, but that's exactly why we developed the tool.
A couple of questions here that came up, Philip and Andre, that kind of got a little bit combined, but one of the audience asked, does house wrap have a perm option? And then where was the other one? I think it was asking if in the future, are you going to will the system be able to talk about the different types of house wraps, realizing that, different house wraps have different perm rate?
Yeah. Go ahead, Phil.
I was just going to mention that if you click on the help, sometimes that'll help with telling you what we have picked. So at the end of this help screen, it says house wraps. As far as the way we're defining them here, they're very permeable, in excess of 50 perms. So if you have a house wrap that's outside of that category, you might pick something else on the list to represent your perm rating. But as we're talking, that does bring up a good point that it would maybe be good if we make sure all that's described somewhere in the tool for somebody to get to if they really want to know.
To make the tool workable, the way that we treat all of these different categories is to lump them into bins. And as this help section is suggesting, water resistant barriers are lumped into basically three categories: impermeable, kind of moderately permeable, and very permeable. So right now the tool won't differentiate between a house wrap that has 100 perms versus a house wrap that has 80 perms. It's going to treat both of those as being identical. It doesn't have that level of granularity to limit the rule set to the 3 million combinations that we have. We had to make those compromises and bin a lot of these properties together. If you're in a situation where you want to look at that kind of detail, then you really need to bring in an expert and have them run a hydrothermal model. That's the only way that you're going to get that level of detail. The building science advisor doesn't offer that at this point in
time. Another question that came up here that I thought was a pretty good one is, are there any options for open joint cladding? Because that's kind of becoming more and more popular.
the cladding here. So no, we don't currently have an open joint cladding option.
Yeah, and that might be something to consider. You know, open joint cladding is almost like having no cladding, and you're getting, you know, your rain being deposited on whatever is behind the cladding, which I presume is a water resistant barrier. The tool doesn't capture that right now. You could put no cladding, but what's going to happen is the tool is going to now assume that the solar and all of the other impacts are striking the water resistant barrier or the next layer into the wall. And that's probably not a fair way of assessing the wall performance. So I think Philip is correct in that. Right now, I'd be a little nervous about using this tool for that type of cladding system.
Another question that I see here is, are we able to take into account mechanical versus adhesive when it comes to an EFIS type system?
Right now, no. The inputs in the database right now are primarily those that impact the moisture performance. And I guess you could argue that whatever you're using to adhere if you're using an adhesive to adhere the insulation in an E system, then that layer could impact the moisture permeability. But right now we don't capture that difference as well. That's not captured.
There is, when you go to CMU and you look at the different claddings that you could put on that, there are some of the rules that will make a note of if you have metal fasteners, you need to watch out if you use certain systems that they may rust and things like that. But other than that, there is no, it doesn't affect the durability rating itself.
Oh, I got my audio, but not my video. There we go. I thought it was kind of from another attendee. Adam asked, does this program have limits that don't allow someone to create a wall assembly that isn't buildable? For instance, he had said adding more than 4 inches of insulation into a 2x4 assembly.
I don't know that, Philip.
How foolproof is it?
Yeah, so just to clarify that, so the thickness for here is for continuous insulation, so that's not in the cavity. These are default, gives you either 3.5 inches or 5.5, you know, if you're in a 4-inch or 6-inch stud. However, you could probably build up a wall that you wouldn't want to build in real life. Whether one that's impossible to build, I don't know about that. I haven't tried.
Hopefully we're all good enough at knowing what we want to build before we get on here. So.
Right.
And I thought this was kind of another question I was asked is, would this be helpful for clients reviewing costs? You know, because I know in my business, a lot of times just even looking at competition, you know, we're building a better wall system maybe than somebody else. I think this would be great maybe to review with the homeowner to let them know why we're doing all the extras.
Yeah, there's no cost information built into the BSA tool. We actually had a lot of discussion about that and became concerned about the fact that as soon as we released the tool, it would be out of date. And you know, market pressures impact the cost of systems as well. So it doesn't include any costing information. I mean, you certainly can create. One of the things that Philip didn't show is that you can actually create and display numerous wall systems at the same time. And so you could, for a client, you know, say, okay, here I've got, you know, system 1, 2, and 3. all of these are going to work in your climate for what you're trying to accomplish. And this one costs X, Y, and Z. So you're going to need to supply the costing information, but you can show using this sort of screen a family of systems that are all going to perform, and then offer your own costing information for what's involved in constructing these. And now you're going to need to argue, since our tool doesn't really have, it's showing paths. It's not showing any granularity in what is more durable than another. And this is one of the benefits of this probabilistic analysis. What we could do when we get to that point is say, okay, if I build this, 87% of the time this is going to be fine. But if I build this other one, 93% of the time it's going to be fine. And so I've got a little bit more of a durable system, but it's going to cost me X dollars per square foot to accomplish that. And so, Mr. Builder, Mr. Homeowner, is it worth it? Here are your choices. Here are the prices. You pick what you want. So we hope to get there in the near future to offer, again, something more than yes, maybe no, what the tool set offers right now. But even as it is configured, you can show a variety of systems that will perform and add costs, and then argue, why would you want to spend this extra money? What's the benefit of doing that? But that part is on you to get that information together.
So that brings probably to a good wind-up question, as we are at 2, and we should wind it up shortly. But I think a good wind-up question came from the audience in, is there a way to go on and be told what the perfect wall is for your building in your climate?
No. A lot of people toss around the terms perfect wall, and in my humble opinion, that means different things to different people. A lot of times when you look at the designs of these perfect walls, their budgets break the bank. So is that perfect? I'm not sure that's perfect. If you can't sell something, then it's not perfect. I mean, we can build a wall system that will not fail. Let's put a 1/4-inch steel plate on each side and guarantee it doesn't leak, and that's perfect. But is anybody going to build that? I don't think so. A lot of people recommend using no cavity insulation and having all of the insulation as continuous insulation. And that's typically a good choice in terms of moisture durability, but now you're paying a whole lot more for that insulation than you would if you use cavity insulation. And now you've also have fairly extensive lengths of fasteners that you're hanging your cladding from, and it may be perfect from a moisture durability perspective, but is it perfect from a construction perspective, and is it perfect from a structural perspective? So the term perfect has kind of been tossed around a lot by a lot of people, but it's always aimed at just one feature. And right now, I guess, being representatives of the Department of Energy, we don't want to tell you what's perfect because we don't really know. But I think, again, this is a reason for the tool. You can create systems and demonstrate that they're going to perform well. You can create a whole family of them, and you can come up with the most cost-effective one for your structure and your climate. In my mind, that's the perfect wall for that building.
Thank you very much, Andre. I think we're going to wind up our hour with you gentlemen here. Thank you so much to Gavin from AI Restorations, and to André Desjarlais and Philip Boudreaux from Oak Ridges. I'm just going to close with a little bit of information about Dorken with the sponsor. And just to remind everybody this webinar is being recorded and will be made available, and you will all receive it. Here at Dorken, we focus on providing you with the best information we can to help you build the best walls. That's why we had the experts from Oak Ridges on today to help provide you with a tool to do that. We do a wide range of products. We do below grade foundation protection systems featuring our well-known brown and orange Delta MS. And also one thing that was a topic today was Delta Dry, that provides you with an airspace and drainage behind absorptive claddings. It is an engineered rain screen. This shows our newest version of it that has a factory pre-applied glass lath, so that you don't have to apply a metal lath on in a second round. This goes on all at once. It goes right over your water resistive barrier. This is an example of a project that was recently completed with Delta Dry and Lath. It's a stucco project in Lockhart, Texas. If you would like to see more of that, there is a video of that on our YouTube channel. Coming up, actually posted right now, I'm sorry, is the newest version of our Cup of Joe, featuring Dr. Joe Stiebrick, which is also available right on our Building Science Deconstructed channel within the Dorken YouTube channel. Look for Joe's Cup of Joe every week. Thank you again for joining us for Building Science Deconstructed. We look forward to seeing you again in 2 weeks. Thank you.